Throughout this training, you heard me talking about helpers. So, what is a helper? A helper is simply a function that can be reactive or not. They exist to help you perform logic around data, especially states. I'll import the helper function here because we will be creating reactive functions. I have this simple counter example where in the previous video I showed you how to create effects using the effect helper. And the effect helper exists to perform side effects on state value. If I add a function to the template to double the count and render this result, nothing happens. This is because markup template does not know that this injected function uses a state getter inside. One way to fix this is by using the effect helper, which I first comma separated list the states that my function depends on, then provide a function that performs the side effect. If I retry this in the browser, we can see that this works just fine, and we are reacting to the count value change to update a different place in the DOM. This is an example of what a helper can do for you, and the effect helper is simply a reactive function. But let's improve this. I'll go ahead and create a val doubler, which will simply be our effect function here on line 9. To improve this, I'll take a value instead of referencing the count state directly. This will make so val doubler can work with anything. I'm using TypeScript here, so I'll tell it that this val is a number state getter. Let me also rename it to a num instead. And I'll update this so it's a function that calls this val doubler, and the effect still remains the same. This is kind of ugly and robust. Really what I want is to simply call val doubler inside the template with state and let it work. But this won't work. And as you can see, val doubler is simply a function that takes a getter and returns a value doubled. It renders the state value the first time, but it's not yet reactive to the change. To make it reactive, I'll wrap it with this helper call and try again. And as you can see, it now works. And that's how you create a reactive function. So how does this work? First of all, a reactive function must accept a state getter directly as argument, something to react to. Then we can wrap this with the helper function. And what this does is create a function that, once called, will return helper instance, which the markup template handles very well. We can also improve this helper to additionally take normal value, in our case, a raw number. Markup exposes the val utility that it uses internally, and I can call it to extract value from the argument. In our case, the count. I can also specify what value type it will return. Val is very special because it also handles helpers. That means if you nest helpers, it will be able to extract their values as well, allowing your helper to be more generic and flexible. To show you what helper wrapper here does, I'll call the val double, for example, 12. And what this does is return a helper instance, and this instance has two properties, the value and the args. Value is what the template will render, and arg is what will tell the template if any of those are state getters, so that the template can subscribe to update the DOM with the value continuously. To show you how useful this val utility is, I'll nest val doubler to double the count, and we can see that this works just fine. With just helper function and val utility, you now have a reactive function. And you can grab any function and add these two things to make them reactive. That's really powerful because it lets you compose functions to perform complex calculations without the need to manage subscription, and all can be used directly in the template. For the final touch, I need you to know that helpers can also have an internal state using function scope. For now, I'll return a function that returns this value doubled. You can see that this still works fine. Markup template expects up to one level function nesting, allowing you to create closures for even more powerful helpers. I'll go ahead and create a cached value to represent a cached data. This will be the limit. And I'll simply return a new double value as long as the value is less than our internal limit. We can try this and see that it works just as expected. This scoping capability is something you can use for tracking, caching data, or minimize complex data calculations for every change. A few of built-in helpers by Markup use this capability to optimize render, and you can use it to create powerful reactive functions in Markup as well. Play around and explore so you really understand helpers, and I'll share with you a couple more helpers in the upcoming videos.